Welcome in our third video, where we are looking at the climate scenario. So we will start with the tab 2A, Input Climate Scenario Passenger. In this tab, you can enter the input concerning your climate scenario for the passenger transportation system. You can see at the top of the tab, you have the overview of the results so that you can see the impact of what you're entering on your kilometer here and the GHG emission reduction. Currently, we have done nothing, so of course there is no difference between the BAU and the climate scenario. The VKT stays stable. We will change that afterwards by entering some measures. Of course, you can read this description. Be aware that you have to choose between two methodologies, as it was the case for input-based and BAU in tab 1A. You have one approach that is based on a transport planning tool or model. If you have those for your city or your country, please just enter the results of this model, which are actually two of them: the vehicle kilometers traveled in million kilometers for each of the different categories that you have, and the transport performance in million passenger kilometer. You can enter in this table. If you do that, you just don't have to do anything else for the first phase, and you can go directly. That's the shift. It's not concerning you at all. You can go to improve because you already did your avoid and shift measures into your transportation planning tool. So you just have to say what's the share of fuel. Are you having more e-cars as before, or are you improving the efficiency of your cars? But for the point concerning vehicle kilometer, it's quite quick. It's just on top here. You have already done the work. If you don't have any transportation model, then you have to do it step by step. That's the second methodology. From here, without upstream calculation, you have to start with the avoid phase. So you bundle all your measures concerning avoiding trip, sorry. And then you enter in this table here the share of avoided motorized trip following the implementation of your measures. So let's say in our case, we have different measures, for example, home office, as we are doing currently for coronavirus. And we say that for the 2 years, 2020, 2025, there is 0.5% reduction of the vehicle kilometers for private car. We decide that for example, for the minibuses, we are doing policies to reduce their number, to reduce them. For example, we make a limit to the number of minibuses that are allowed to operate in our city. Then we guess that it's around 1% reduction of the vehicle kilometer of the base here, as it is shown. So 1% reduction of the almost 260 million kilometers. That's the first phase. As you can see, you can start seeing the effects of what you are doing. So you're already having almost 1% reduction from 2025 on. And that's the avoid. Important point, just pay attention to how many kilometers you're reducing, because 1% of 3,000 million kilometers, it's a lot. So really calculating kilometers, how many kilometers you can avoid. And when you're done that, then you can translate it in percentage of your base kilometer here. And you see the results on the right side, how many kilometers here you have after you implement these measures? Well, the second point is the shift. Of course, we are in a climate scenario, so we want to shift the people from the private cars or the private vehicles to the public transportation system, or to bikes, for example. So the logic of the thing is you have to give the potential increase of the sustainable modes, which are in our case non-motorized, minibus, bus, BRT, long-distance train, urban train, and metro. And you can give the occupancy rate of those. So that means I am developing the offer for my sustainable transport system. I say I give how many kilometers will be done with my sustainable modes and how many people will use these modes. And I give afterwards here where it comes from. So the origin of the new person kilometer that are in our transportation system, sustainable transportation system, where does they come from? That's the logic of the shift. Let's do an example. So we start with the additional VKT. If you have, maybe that you don't have, just working with occupancy rate. We have some additional VKT. We say 2025 because we say the minibuses cannot run as they want in the city. They are limited. We increase the kilometers of the buses to compensate, to offer more lines to compensate the disappearance of the minibuses. And we also decide to increase the offer of the tramway, and in 2030, because it takes a bit more time to implement, to build, and we add then 0.4 almost million kilometer. So that's the results of all the measures we decide concerning additional kilometers, additional vehicle kilometers. Another point is the occupancy rate. So we have more buses, we have more trams, at least they are running often. But the question is how many people are in there? In our case, we say we stay stable. Here you have the occupancy rate of your base. So currently there are 20% in average in our buses. And we say results of another measure that we plan, that is the decrease of the price of the bus ticket, that we have more people in our buses. So we say we have 22 people in average in our buses. So as you have seen, it's a bit strange because now the emissions are bigger in the climate scenario than in the BAU. Like, what is going on? So the VKT are a bit reduced as normal with the void measures, and now we have much more emissions. Actually, it's because there is a very important field to fill in. It's this one. You have to say where these people are coming from that are using buses. If not, there are additional persons. They are not disappearing from any other vehicle mode or any transportation mode. They are just popping up into your system. So you have to say, in our case for the buses, we have more buses where the people are coming from. So it's in percentage of the trips. You can just do a survey in your buses on the lines you added, for example, and ask the people which type of vehicle they had before, what they were using for the trips, and enter the results in it. So, for example, I completely made up this result. Of course, I didn't do any survey. 70% of the people are going from private cars, 10 from taxis, and so on and so on. And so we have also to, so once we have done for the buses, we have to do the same for the urban train. Here, I take the occasion to show you a mistake that may be possible, that you don't have actually calculated what does it mean to reduce with 2% or 60% the number of persons that are coming from your original mode. So that means we say that 60% of the persons that are now using the tram were previously car users, private car. And you see the results here. What does it means for you actually in kilometer? And if you say, actually, I say 60% of cars and 10% of taxi, and we have to go to 100, of course. And we say motorcycle, and it's also 5%. And like, oh, what's going on? The value you entered leads to negative vehicle kilometers for this transport mode. Please adjust your input. Actually, you have seen below, if I enter here, it's in red, because if you say that 5% of the new tramway users are coming from the motorcycles, actually the number of kilometers of motorcycles is negative, which of course can't be the reality. So in this case, for example, actually I say there is nobody coming from a motorcycle. Originally, I planned that people are coming from the bus, the minibus, quite a lot from the bus system, because there are a lot of people in the bus system. As you can see, I have very little motorcycle. Most of them were transferred from to the buses. You can check the results afterward and ask you if it makes sense. For example, here it's quite a big step from 15 to 1.2. That would be maybe too big, actually. So just review a bit your values and check if it's rational. In our case, just 10% of the trips of the person that are now in the bus were previously motorcycle drivers, and that makes already quite a lot. So you may say that cannot happen, and we kind of recalibrate. Of course, it's not a perfect science. If you want a perfect science, you have to use a transportation planning tool that's done for that. Here we are just trying to approximate and have a result that we agree with expert guess and surveys and so on, but it will never be perfect. You will have to adjust and think about your results. So now we are through for the first point. So the second point, shift. So you have the results here in terms of million kilometer and person kilometer. You can see the results of your activities here, what you have done, how it impacts the GHG emissions. And you're going to be at the same level as the person that had a transportation model. You're going to improve. So improve means which the consumption of the vehicles, either by using sustainable fuels such as electric cars or hybrid cars or buses. That's the first option. So here you have your BAU values, what you entered, and here you have your climate scenario values. So for the sake of the example, I will change for private cars, for example, and I say that private cars, the VKT share is a bit higher as here in comparison to the BAU. So for example, I give from 2030 on, because we plan to have a measure to increase the share of e-cars more than it was already planned, maybe. And we give new percentages, and we say that we have 15% of e-vehicle, at least 15% of the mileage is done by e-cars. You're aware it's not a question of fleet, it's a question of kilometer. For example, check that you have 100%, I have 100%. And maybe we can say for the buses, because we have a lot of buses actually in our city, that we also have to do something for that. And that we plan to have, for example, from 2025 on, we plan to have natural gas buses. But not so much, because it's quite a expensive technology. You have to have refueling stations and so on. So we plan with 2%. So as you see, you're starting to increase your savings again. And finally, we have the specific fuel energy consumption. Are on average your car is consuming less. It may be because of policy to which give a price to the CO2, and you have a correlation with the price of cars, for example. And the tiniest cars, like the compact one, are less expensive than your SUVs at the end of the day. So it could be that you've reduced in average your fuel consumption, for example. And we say instead of 7.5, we have 7.4. And here we have 7. And we finally have 6.5 liter per 100 kilometer for gasoline cars. And maybe we do the same for diesel. And we say 5.5, 5.2, and 5. So, of course, it's possible for all the other ones. In order to be short, I don't do the rest. So you're at the end of your climate scenario passenger. As you can see, it's very quick if you have already the kilometers. So if you have the transportation model, if you don't, it takes a bit more time. Here you can see the results that you have. And we can go to the next, which is the freight scenario. So now we are in the tab 2B, input climate scenario for freight. This is exactly the same. It's the same logic, the same structure. We have on top the results in terms of VKT. As we haven't done anything for the freight sector, we have the same VKT for BAU and climate. We have the GHG emission reductions, of course, 0% environment. You should read the introduction. This is the same warning. This is the first methodology. The second methodology is the same with upstream calculation. So we have a transport planning tool. We just enter the data into these two tables in million kilometers and million ton kilometers. And then we have the results of our measures in terms of mileage and demand. If you don't have it, you have to use the second one without upstream calculation. And then we will just meet at the end at the 3 improve. So as the first one is quite straightforward, I don't do it. As for passenger, I choose the second methodology, the avoid, with avoid first. So we will do a quite simple example in this case to reduce the time for you to look at these videos because it could be a bit long. and you will anyway play with your tool afterwards. So for the avoid, we say in our freight system, we plan to have a reduction of 1% of the motorized VKT for the light commercial vehicles in 2025. This is due, for example, to a new distribution center in the outskirts of the city, which aims to reduce the numbers of kilometers and be more efficient in the tracing of the route. Be aware of the fact that this method is quite, you have seen it, it's a bit uncertain. Now, of course, you don't have any model and you're then doing assumptions using experts, values, surveys, and so on. It's for the fact for passenger, but it's even worse for freight because, of course, it's very complicated to plan the effects of measures for such a system that is based on efficiency, on routing, on different companies that are using different strategies. And to plan that without any model is quite complex. So we really recommend to use the first technique, so the first methodology with the tool. If you don't, of course, you have to do with this second one, but be very, very attentive to what you're doing, the numbers you're doing, why you're entering the data. Yeah, it's a very complicated field of freight transportation. So take care of doing the things slowly and checking what it means, and maybe talking with a lot of experts on this point. The second point, so we have shift, so it's the only thing we plan to have here. There is no other measures in the avoid field. In the shift, we plan to have one measure, which is the increase of the LCV kilometer of with, for example, 15 million kilometer. No, something else. So we go to the second point, the shift. And for the shift, we plan to have a change in the vehicle kilometer. And we focus on trying to reduce the emissions. So we may say that we want to, for example, let's say, shift some LCV to the solo trucks so that we have a bigger truck that is full, and we reduce then the number of vehicles on the road, let's say in the outskirts of the city, because solo trucks, of course, in the city center, it's not quite cool. So in 2030, we say that we have, for example, 15 million kilometers for solo truck, more because they are transferring from the light commercial vehicle. So we say for the load, actually it's complicated to know how many vehicle will be replaced, what does it mean for the load of each of the vehicles. It's the reason why we recommend using softwares to do it. Like quick calculation is not an easy thing. In our case, we simplify a lot and we say that we increase a bit the average load per vehicle for the solar trucks, because we try to be more efficient, and for the LCV it stays the same. So, sorry, it's 2025. It's a bit misleading. We are working in 2020, 2030. So the two of them are in the same year, even if here we have 2018 to have the base, so you know the values for the load of the vehicles, what you have currently in the system, and you can then say put a bit more, a bit less. That's why it's not lined. Sorry for that, it's maybe a bit misleading. Pay attention to that. And of course, the same as for passenger, then we have to say where it's coming from. So we say that it's coming from the majority of it is coming from the LCV, because we want to reduce the LCV, maybe 70%, and articulated truck for the rest, because we don't want to have super big trucks, but just solo trucks in our suburbs or in the outskirts of the city. You can see the results of your action here. The results are also here in numbers. And then we get to the point 3, improve penetration of alternative energies. There are not so many alternative energies for trucks. For the big ones, it's not quite usual to have a lot of alternatives. For light commercial or very light, we don't have any very light in our city currently, but if you have them, you can also have electrification. There are some other technologies, of course, but not so many of them are available currently, at least at a affordable price. What we say is that we are trying to electrify our fleet of the LCVs. Maybe we work with post system that they change their fleet and have then LCVs, for example, so that we can plan a bit what it means in terms of kilometer. And we work with one of the big delivery company of the city. So, for example, we say that we are increasing a lot the fleet of electric vehicles. As I remember, percent of the VKT, not percent of the fleet. Huh? And for specific fuel energy consumption, we actually, for example, we don't know how the fleet will evolve. We cannot really say anything. Then you can just let it as it is, or you have some projections. You have talked to the big companies, and they are saying, yeah, we are renewing the fleets every 3 years, so we expect to have better consumption in 20 years or in 10 years, and then you can enter data here. Be aware that you have to make an average on the global fleet. As an example, as we focus on LCV, we are trying to maybe to reduce a bit, but we see it takes a lot of time. So we just start in 2030 to have a result of our measures, to maybe help companies to change their fleet, or maybe just because they can't invest for the moment, but they are planning to do it. So we reduce a bit the consumption, but we say that, for example, it will bring some improvements, but until 2040, and afterwards we can't project, so we just let it as it is in 2040. Just think about the fact that if you don't put any data on that, the software will take this data. So even if there is no improvement after 2040, just put the data again in 2050. If you don't, the system will take this value. Well, we are through. The freight is always a bit easier and we haven't done so many measures, but we can see that we already have some improvement, definitively. Not so much in 2025 because we're just starting 2025, of course, but on the long run, it's paying to, in our case, focus on LCV. We don't focus on anything else. So as you see, solo trucks are not improving at all, almost not. And utility truck is exactly the same, almost, because we have transferred a bit of them, but very few. Well, you're through. You're through. And to end this videos on the climate scenario, the entire series, we go to the 3, because then we see all our results. We see everything what we have done so far. Is the final tab, let's say for the users. You have the definition as always. Here you have to choose, I talked about it in the first video with the PowerPoint presentation. You have to choose between the type of GHG emission that you want to have, either tongue to wheel or well to wheel. In our case, we want to have the well to wheel actually. So the well to wheel includes the production of the energy production. And we have first on the right side the inventory. You have for road and rail, you have the cars that are doing taking almost 40%, LCVs, the truck and buses, and as you see, motorcycles and rail are really low. Rail, you have emissions because of course you are in well to well. If you're in tank to wheel, you can see that it's disappearing because of course electricity. You don't have emissions by using the electricity into the cars, but you have emission because you produce electricity. So here it's appearing in the rail. So rail is currently for us tramway. You have the result here. And in megaton CO2 here. And you have afterwards the results of the scenario. So BAU and climate. You have in this table the total GHG emissions in the BAU and in the climate scenario for the different years up to 2050. You have the differentiation between passenger and freight. So you can see that we have reduced quite a lot the passenger emissions, but we also had quite an effect on the freight. So we are kind of almost on a balance between freight and passengers right now. You have the reduction here given in numbers for the difference between BAU and climate scenario. So we end with 17.4% reduction in 2050. But we already have as you have seen, we have done a lot in 2025 actually. So the biggest jump is here from 5% reduction to almost 14% reduction. Here you have, if you needed the cumulative GHG reduction, GHG emissions reduction in 1,000 ton, 2020, 2025, we cumulate it. So be aware, it doesn't mean that you save this amount in 2040, but that means in 2040 you have saved such an amount from the beginning. Yeah. And that's in green the total. So if you want to add the two. So that's the amount of GHG emissions we have saved from two scenarios, passenger and freight, for the climate scenario, of course, at the end in 2050, when we add on the entire period. Finally, you have some key performance indicators here that give you an idea of where you stand currently. So for example, we have the ton of CO2 per inhabitant for the transport system actually, and then in the next years, you just have until 2030 because afterwards it's not so easy to project after 2030. At least for us, it means 10 years. After that, it's kind of a trend, but to have really special KPIs for 2040, where everything is kind of the result of a trend of big assumptions, it's not so useful, let's say. You have in green here the different KPIs that are required for the MYC report, so you can use them directly. You can see 3 of them that are not given because they are not in the tool. It's something that's not calculated with by the tool. It's the accidents, the number of people in the service area of public transport, and the average commercial speed. Of course, it's not at all the subject of our tool, but we have a space here so that you can enter the data and have in one table all the KPIs you need for MYC. So we have the general KPIs, the passenger transportation KPIs, and the freight transportation KPIs. You always have the indicators, the explanation of it, and the unit. So you can go through it and look at the different ones and ask yourself, does it make sense? Is this what I want to achieve? To, of course, do a workshop maybe with other persons of your city or of your country or the ministries to see if they agree with that, if it can be taken as a political goal, for example. In our case, we have, for example, if we take the share of individual traffic in passenger transport in percentage of the PKM, so model split actually, we have individual and public here. We have individual at the end, which is 40%, and the public transport is 60%. So it's quite a good result actually. We start by almost 50-50, not entirely, but almost. So which is already quite okay. But we are kind of ending with a good result. So you have to talk with your other persons to see if it's reasonable to have such a result, and if you want to give you this goal, and you can follow then within the years. If you do this exercise again, and that you change the base year, and you do eventually the projection, the BAU projection again, you can compare with the different versions and see in which way you reach your goals or you didn't, or where you stand actually. So that's all for this video. The final one is the one for expert version, let's say. You can decide if you want to see it or not. There are some tabs here that can be used. Much of them is really quite specific stuff. You, as a normal user, you absolutely don't have to do anything in the gray tabs. So feel free to look at the video, see if it's interesting for you or not, the expert video. So now we are at the end of the video for using the tool. Thanks for seeing the entire time, so that you've seen all the videos. It's quite difficult tool. I hope now you understand how it works and you had fun to learn, and you will have fun to use it. If you have any problem, don't hesitate to contact the MYC Secretariat, and I wish you all the best. Have a very good day.